Conditional statements and counterexamples. Before we begin the notes, please take a moment and try to complete this warm-up by yourself. It should be very basic. You're determining if the following statements are always or sometimes true. If sometimes true, describe one event that proves it false. So please press pause on your video, take a moment, answer these two questions. For number 1, if it is raining, then there are clouds in the sky. I would say that's always true. Based on what we know, I would say always true. For number 2, if the sun is out, then it's warm. I would say sometimes this is true, and my most basic counterexample or event that proves it wrong could be winter in New England. For example, it's sunny out today, but it's not really warm out. The first term we're going to talk about is conditional statements. So a conditional statement is a logical statement. It is specifically an if-then statement. So you're going to say, or you're going to see something that says, if the forecast is rainy, then I will take an umbrella. That's the first example we're going to go over. So conditional statements contain a hypothesis and a conclusion. So for the rest of the notes, I'm going to highlight the hypotheses in orange, and I'll highlight the conclusion in purple. The hypothesis is always the part following the if statement. And the conclusion is always going to be the part following the then statement. For the first example set, we are going to identify the hypotheses, which I'll highlight in orange, and the conclusion, highlighted in purple, of each of the following statements. Number 1, if the forecast is rain, then I will take an umbrella. So we're going to say that the hypotheses, the part following the if statement, is the forecast is rain, and the conclusion is going to be the part following the then statement, and it's I will take an umbrella. So please write these out. Just to save some time, I copied those, but the hypothesis, like we talked about, is the forecast is rain. The conclusion is I will take an umbrella. Number two is written a little bit different. It's actually not written as an if-then statement, so you might have to rearrange what the statement says just to identify your hypotheses and conclusion. If you can do it without rearranging, then that's perfectly fine. But number 2 states that a number is divisible by 10 if its last digit is a 0. So the hypothesis always comes after the if. So we know this right here is going to be the hypothesis. Here's your if statement. In case you cannot identify what the conclusion is here, you can rewrite this statement. And occasionally you'll have to do this. Probably not very often, but I wanted to make sure we did one in our notes. If I rewrote this using our if statement first, I would say if a number has a last digit of 0, I know I'm rewording it, but I'm just trying to make it make sense. So if a number's last digit is 0, then the number is divisible by 10. So again, you don't have to do this if you can easily see it right from the statement, but if you are physically looking for the if-then statement, you're going to have to rewrite this. So if a number's last digit is 0, there's your hypothesis. Then the number is divisible by 10 is going to be your conclusion. All right, so number 2 and our rewriting situation that we did over here leads us into the next set of examples, which is writing a conditional statement. So for the next set of examples, I gave you some situations, and you need to take these and write them in if-then form. So basically what we just did on number 2 up here above. So one thing that I can say to you, and you probably noticed me doing it in this previous problem, is that you need to make sure your statement is logical and understandable. So you need to reread it and make sure it makes sense. You might have to add some words in. You might have to take some words out. Compare what I did on number 2 above. The original problem said a number is divisible by 10 if its last digit is 0. When I rewrote this, I added if a number's last digit is 0. So I did add some words in there to make it make sense, but you should be able to hand it to somebody else. They should be able to read it and understand exactly what it's saying. So for number 1, the statement given to you says, when x equals 9, x squared is equal to 81. If we turn this into an if-then statement, I'm going to write if x equals 9, comma, then x squared equals 81. So I know that my hypothesis is x equals 9. I know my conclusion is x squared is equal to 81. All right, I did get rid of the word when. It wouldn't have made sense to leave that in there. I can't tell you what words to get rid of. It's obviously a case-by-case basis. All I can say to you is make sure your final statement makes sense. Number 2, the situation says the measure of a straight angle is 180 degrees. So we're going to have to add quite a bit in here. My statement has a straight angle, so it mentions a straight angle, and it also mentions 180 degrees. So I'm going to turn this into a statement that says, if an angle is a straight angle, then the angle measure is 180 degrees. Now, you may write something slightly different than me. That's completely fine. You just have to include all of the correct information. To highlight your hypothesis, that's going to be an angle is a straight angle, and your conclusion is the angle measure is 180 degrees. And for the last one, number 3, Why don't you all try to press pause on your video and complete number 3 by yourself. Compare your answer to the one I'll write on the video or on the note sheet in just a moment. So what I would say for number 3 is I would take the part of your age and make it the if statement, and I would take the part of register to vote and make it the then statement. So I'm going to write, if you are 18 years old, then you will be able to register to vote. My if statement or my hypothesis is you are 18 years old. My conclusion is you are able to register to vote. Next, we're going to learn about counterexamples, which we briefly learned about in the last note sheet, so this definition is slightly repetitive to last class. This says that a counterexample is at least one example that proves a conditional statement false. And I just want everyone to note down here that I will abbreviate it sometimes as CE, just to save myself some time of writing. So counterexample CE. So the truth value of a conditional is either true or false. Those are your only options. To show that a conditional is true, show that every time the hypothesis is true, the conclusion is also true. To show that the conditional is false, so to prove that your statement is not true, you need to find one counterexample for which the hypothesis is true and the conclusion is false. If you can do this, then the truth value of the conditional is false. For the examples, the directions state to determine the validity or the truth value of each conditional statement. If it's false, state a counterexample. You only have to state one counterexample. So number 1, it says if an angle has a measure of 100 degrees, so an angle has a measure of 100 degrees is your hypothesis, then the angle is obtuse. The angle is obtuse is your conclusion. So is there ever a time where you can prove that conclusion to be false? So if you have every angle on your paper is 100 degrees, could you prove that any one of them is not obtuse? And you couldn't. This statement is always true. No matter what, a 100-degree angle is obtuse. That is all you can ever prove. That is true. Number 2 says if angle A is an acute angle, then the measure of angle A is 35 degrees. Angle A is an acute angle, is our hypothesis, and the measure of angle A is 35 degrees is our conclusion. So of course, your if statement or your hypothesis, that's going to be true. It's a statement, it's true. But we can prove our conclusion wrong on this example. So acute angles measure between 0 and 90 degrees. So if this is the case, if acute angles measure between 0 and 90 degrees, this is specifically telling us the measure of angle A is 35 degrees, but just one single counterexample could be anything between 0 and 90 degrees. You could say the measure of angle A is 55 degrees. That still makes this true. So here, this here is called my counterexample because it's one example that proves that conclusion to be false. The conclusion can be any angle between 0 and 90. So my one counterexample is 55. You could have wrote 62, 17, any number between 0 and 90 would have proved this to be false. So this statement, this conditional statement, is false based on our counterexample. The next term we're covering is a converse. So the converse is formed by exchanging the hypothesis and the conclusion of the related conditional statement, which means you are switching them. So you literally take the location of each one and you change it. For the examples, you're writing the converse of each given conditional. Same note as before, make sure your final answer or your final statement makes sense. Someone else should be able to read it and understand what it means. So previously, we sometimes exchanged some words or swapped some words out to make it make sense. You're gonna have to do the same thing here. You can't literally just switch your if and then statement. Sometimes you have to rework the language to make sure that your sentence makes sense. So for number 1, we're given a conditional statement. This here is a conditional. We need to write the converse. And the converse is found when you switch your hypotheses and your conclusion. The hypothesis says you can fly a plane. The conclusion says you are a pilot. So we need to switch them. So this one works out nice because you literally can keep everything the same and just switch your if and then statement. I'm going to write, if you are a pilot, then you can fly a plane. Again, we just switched them. For number 2, we are going to have to switch the language. So read over number 2 and think about how you could write a converse based on the conditional that's given. All right, hopefully you've all had a moment to read over that and see how you would write it. But the original conditional says if two lines intersect to form right angles, then they are perpendicular. The hypothesis is two lines intersect to form right angles. The conclusion is they are perpendicular. So I already made a note. It says slightly change the language so the statement makes sense. But when I switch this, I can't just say if they are perpendicular because what would they mean if I said that? So I have to say if two lines are perpendicular. I have to be specific. I have to make sure it makes sense. So if two lines are perpendicular, then they intersect to form right angles. If you just switch these and said if they are perpendicular, then two lines intersect to form right angles, I would take points off for that because the original hypothesis does not indicate what they are. So be very careful. Make sure your entire statement makes sense. And the last term we're going over today is called a biconditional statement, which is definitely the most complex one because it's multiple statements that we're dealing with. So a biconditional statement is when a conditional and its converse are both true. You can combine them as a true biconditional using if and only if. So this is going to sound a little bit crazy because we haven't seen one yet, and this is definitely the most complex. So please just write this definition down, and then hopefully when we go through the example, you will see more of what this means. But now we're dealing with if and only if. I also want to highlight the statement I have down here. So we have a biconditional that's written with the first part, that's going to be the conditional hypotheses, and the second part, that's going to be the converse hypotheses. So we never actually use, or we don't use either of the conclusions. For the examples, we have to write the converse of the statement below. If both the conditional and the converse are true, write the biconditional statement. So you can only write the biconditional if both the conditional and the converse are true. So please pay attention. You might want to just watch me do this one and then press pause, go back and write down what you need to. For number 1, the conditional statement says if two angles have the same measure, then the angles are congruent. So if two angles have the same measure is your hypotheses. The angles are congruent is your conclusion. So to write the converse, you're going to have to switch these. And when you switch them, you have to make sure that your language is correct. So I'm going to say if two angles are congruent, then they have the same measure. All right, we need to check these. We need to check the conditional, we need to check the converse. We need to determine if they are true. So the conditional says if two angles have the same measure, then they are congruent. That is true. We could never prove this conclusion to be false. That is always true. The converse states if two angles are congruent, then they have the same measure. This is also true. We could never prove that to be false. So since both of these are true, you can now write a biconditional. If one of those top two statements was false, you could not write a biconditional. But in this case, we can. Looking back up at the converse, the hypothesis of the converse is two angles are congruent. The conclusion is they have the same measure. A biconditional is written like this. So we write the conditional hypotheses, and then we write the converse hypotheses. So I'm going to start by writing this. So I'm going to say two angles have the same measure. And then I'm going to use a statement, if and only if. This statement is what makes it a biconditional. If and only if. Now I am going to write the converse hypotheses, which is this here. So we're dealing with both of the hypotheses. So two angles have the same measure if and only if the two angles are congruent. And that's your final biconditional answer. The if and only if is the biggest part. Biconditionals are not if-then statements. Please do not mix them up. Number 2, the conditional states that if 3 points are collinear, they lie on the same line. I'm just going to indicate right away, I'm going to mark this to be true. Of course, that's true. If 3 points are collinear, they have to be on the same line. To write the converse of the conditional, remember we have to switch these two. So in order to switch them, I'm going to now rework my language just a little bit and say if 3 points lie on the same line, then they are collinear. My new hypothesis is 3 points lie on the same line. My new conclusion is they are collinear. This is also true. There is no way to prove this to be false. Because both of these are true, we are now going to write a biconditional. We need to get rid of the if-then statement. So I'm going to start by writing the hypotheses of my conditional. I'm going to say 3 points are collinear. I'm going to include my if and only if statement. And then I'm going to write my converse hypotheses. So 3 points are collinear if and only if the 3 points lie on the same line. Okay, please take a moment and complete the by yourself, sorry. This is different. I'm having you work backwards. I actually think it's a little bit easier than writing a biconditional. So work backwards to write your conditional and your converse. Remember that all the information is included in that. You just have to break it down by identifying the first part is going to be the hypothesis of your conditional. The second part is going to be the hypothesis of your converse, and then obviously fill in those conclusions. I'll put my answer up here in just a moment. Please let me know if you have any questions.